Okay guys, today we are going to finish chapter 1. So I'm going to give you the rest of the information you need to know for your chapter 1 quiz, which is on Friday. To start off, we already went over the acronym I use for the scientific method, which is O quit hating, everyone drinks Coke. We did the O last time, which is observation. We did the Q, which is question. And then we did the H, which is hypothesis. And we worked on writing different hypotheses in if-then format. So you always have to have the if in the end. If and then. If something happens, then something else is going to happen. So we're going to work on the experiment today, do a little data, the discussion part, and then the conclusion, and then we're done. So in an experiment, guys, we're going to have two different groups. So we're in an experiment, you always have to have two different groups that you're comparing during the test. One is going to be a control group, and the other one is going to be the experimental group. So for the control group, this is going to be the group that you already know the outcome of. And I'll go over an example with you guys to better explain it. And then the experimental group is going to be the group that you're applying a variable to. Real easy example, guys, is this. Let's say we have flowers, and we are going to use some kind of new liquid potion on these flowers, okay? We might have two groups. One group we are going to give this new potion to, this new liquid that we think is going to help the flowers grow a little bit bigger. That's going to be our experimental group. That's one we're applying our unknown variable to. The other group, well, let's use something we know. Well, we know that water helps plants grow. So in the control group, let's just give them water. We know the outcome of that. We know that giving plants water helps them grow. So that's our difference between the control group and the experimental group, guys. Again, the control group, we know the outcome of. We know what's going to happen. Sometimes we even leave it completely untested. We just kind of let it chill there. Where the experimental group is the one where we are applying our unknown to, our variable in question. In an experiment, guys, we also have two different variables, and we're going to go over some examples of these as well. We're going to have an independent variable and a dependent variable, okay? The independent variable is going to be our cause, and the dependent variable is going to be the effect. Let me give you a quick story. Whenever I was student teaching, the teacher did a little lab where we had goldfish, and every student got a beaker, and we put a goldfish in that beaker, and obviously the beaker had water in it so the fish could breathe. So the goal of the experiment was to change the temperature of the water, without killing the goldfish obviously, change the temperature of the water to see if the fish breathes more or less in different temperatures. So we did this, and we found that as we increase the temperature of the water, the fish breathes more. As we decrease the temperature of the water, the fish breathe less, okay? So the independent variable, guys, is the cause. It is what you can change. It's what you have control over. In that example, there was two things. There was the temperature of the water, and there was the breaths of the fish. Which one were we able to change? Well, that was the temperature of the water. So that's our independent variable. Our dependent variable is the effect, the outcome of that change. So the dependent variable would be the fish breathing more or less, all right? Now, we can't tell the fish to breathe more. You know, I know, like, it's like, oh, well, the fish breathed more. Yeah, they did, but it was based on our change. It was based on that temperature change. So again, independent variable, temperature change. Dependent variable is the breaths of the fish, okay? A few more examples, guys. There was a study done to see how amount of sleep affects test scores. We got two groups. One group gets 8 hours of sleep a night before a test, and the other group only gets 4 hours of sleep. Okay, so we have these two groups. One group is getting 8 hours of sleep. The other group is only getting 4 hours of sleep. Then they take a test. So let's talk about what the independent variable would be. What do we have control over? Well, we have control over how many hours of sleep they're getting, okay? We don't have control over their test scores, just how much sleep that they're getting. So that's your independent variable. And then your dependent variable, the effect of changing that sleep would be how well the groups do on the test, what their score would be. Okay, so there's one example of independent and dependent variables. Okay, one more example. People were once again divided into two groups. One group exercises an hour a day, and the other group is told not to exercise. Two groups are then asked how well they sleep. Okay? But still involving sleep, just like the last example, but completely different scenario. So there's two groups. The change in the groups is going to be how much they exercise, whether it's an hour or not. And then they want to monitor how well they sleep. So what did the researchers have control over? Well, they had control over assigning the groups, whether they get exercise or not. So that's going to be our independent variable. And then our dependent variable is going to be the outcome of that, or how well they sleep. Okay? So there's your difference between the two, guys. Take a second, look at that, make sure you understand it. All right? So again, independent variable is the cause, dependent variable is the effect. So different types of data, guys. We're going to get to the data discussion, that kind of thing now. We have quantitative data and we have qualitative data. Real easy. You go to the self-checkout store at Walmart. Whoa, he went away from science quickly. You're at Walmart, you're at Giant Eagle, wherever, you're at the self-checkout. If you have like bananas or apples or anything like that, anything in the produce section, you'll ring it out and then it'll say quantity needed. And you'll say, oh, I have 2 bananas. So you'll put the 2 in there or whatever. So quantitative data, you see that word quantity in there, it deals with numbers, just like self-checkout. You need to enter the number that you bought. Okay, so anything that has a number in it, guys, is quantitative data. If there's no number in it, it's qualitative data. Okay, so pretty much things like if we have, 5 apples, that's quantitative. If you want to say the apples are yellow, there's no number in there, so now it's qualitative, right? If something tastes bitter, it's qualitative data, all right? If we're talking about you weigh 150 pounds, that's quantitative data, all right? Usually, guys, with the results and discussion, this is where any kind of graphs are put in, all your tables and stuff like that. It shows what happened with the hypothesis, if we accept it, if we reject it, that kind of thing. And then lastly, we move on to the conclusion, which is our last part. All right. So it's just the takeaway messages from the experiment. Okay. What were our outcomes, and what were the what did we want everyone to learn from it? Okay. And that's pretty much it, guys. That's our scientific method. So I have one more example to go over with you guys. And this is a hagfish. I got a video of the hagfish for you. There's no sound to this video, but the hagfish right is there. It's all the way on the ocean floor, and there's a shark. And what they did is they put hagfish bait right here to try to attract it. So just watch, guys, and we'll see what happens. There's, I think, 3 different fish we'll look at here. Shark bites the fish. Shark swims away. And the hagfish is fine. Here's it in slow motion. There's another fish. You can see the hagfish right there by the bait. And one more fish. Oh, he engulfed it whole. Oh, and then he spits it back out. Okay. So, let's talk about what was going on in this video here. So let's use our scientific method and we'll go through everything. So, what the video, the plot of the video, guys, is going to be wondering why the fish, why the shark and those other fish aren't eating the hagfish. It's engulfing them, putting them in its mouth and then spitting it back out. So what is going on here, right? So observation is going to be, so we'll start at off the beginning, guys. Observation is going to be the fish, the shark, spitting out the hagfish. Question would be, well, why is it not eating the hagfish? And then we're going to do a hypothesis. And again, guys, if then, always if then. You always have to be if then format. So maybe, I mean, it looks like an electric eel to me. So maybe it's, you know, if the fish spits out the hagfish, then the hagfish electrocuted the fish. Sound good? It's a pretty good hypothesis, if then format. All right. So an experiment, guys. Well, I don't have a hagfish. So found a video on an experiment of the hagfish. It's not the best quality video, guys, but you get to see what goes on. So there's a hagfish. They pulled it up, and they're going to kind of put an electric shock on it.
Now it's recording. We have 180 seconds.
Okay, yeah.
So I'm collecting some slime.
Yeah.
Can you see?
Oh, yeah.
Gonna mix it.
So the guy took whatever was on the outside, whatever the hagfish, like, you know, secreted, and put it in a beaker of water.
And my official mixing apparatus, let me hold it up.
You gotta back off a bit.
See.
Wait a minute. Well, okay, go for it.
And the entire beaker.
Wait a minute. It is empty. Turn the beaker upside down and pour it out. Nothing.
Okay, so my hypothesis, guys, obviously would be wrong because, you know, it didn't electrocute it. Instead, what it does is if the hagfish feels threatened, there's these little, like, things on its side here, it will secrete this protein out of it, and the protein turns the water into slime. So what it does is once it gets swallowed by them fish, it makes the water all around it slime. That slime gets clogged in the fish's gills. The fish spits the hagfish out. Fish swims away. Fish dies. Hagfish is perfectly fine. All right. That is like the craziest, you know, underwater creature I've seen. It's like, if you've ever seen Finding Nemo, the anglerfish out of it, they're crazy too. But this one's insane. You know, it turns the water into slime. It's a perfect defense mechanism. All right. They are horrifying animals too, or fish. If you look inside its mouth, that's what its mouth looked like. It looks like something out of a scary movie. It has like a jawless mouth, and it literally, once it like a whale dies or something like that, it swims in the whale and eats its way from the inside out. It's kind of gross, right? Yeah. Okay, so let's do two more examples, guys, of independent, dependent variables, just so we know what's going on here and we feel comfortable with them, because your assignment today, you'll have to do a little bit of this. A scientist develops a new peanut for people who are allergic to nuts. He gets 60 people for the study. 30 people are given a new peanut. 30 people are given a regular peanut. After his test, 0 people in group 1 show an allergic reaction. So that was with the new nut. And then 30 people with the regular peanuts show an allergic reaction. So what is the independent variable? So what did the scientist have control over? Well, he had control over what type of peanut they were given. Okay, so that's our independent variable. Our dependent variable is going to be, well, do they have an allergic reaction or not? The outcome of it, the effect, you know. So independent variable, guys, what peanut they're given. Dependent variable, you know, did they have an allergic reaction or not? What is the control and experimental groups? Well, the control group, if you guys remember, we know the outcome of this. So we don't know what's going on with this new peanut. But the regular peanut, if you're allergic to peanuts, you're going to have an allergic reaction if you eat a peanut, right? So our control group is group 2, the regular peanut group. Our experimental group is going to be group 1, because we don't know what's going to happen with that new peanut. We don't know if people are going to have an allergic reaction or not, okay? So again, control group, group 2, the one with the regular peanuts. Experimental group, group 1, the group with the old-fashioned regular peanuts. Last question for today, guys. A scientist makes a vitamin that makes people stronger. One group, group 1, is given the vitamin, and the other group, group 2, is given a vitamin and it just has orange juice in it. After 2 weeks, they test to see if the people are stronger. So independent, dependent variable, guys. Independent variable, that's going to be what vitamin they're given. Are they given the new vitamin, or are they just given the vitamin with the orange juice in it? And in the dependent variable, the outcome of that, the effect, is going to be if the people are stronger. All right? So again, independent variable, what vitamin they're given. Dependent variable, the outcome, are they stronger? Control and experimental groups. Our control group, we know that orange juice should not make someone stronger. So our control group is going to be the group 2, which is given the vitamin with orange juice in it. And then our experimental group is going to be group 1. That's going to be our group with the new vitamin. Okay. All right, guys. That's it. So make sure you do the assignment for the day. It's on independent, dependent variables, and there's a few more questions in there. All right, guys. Also study for your Chapter 1 quiz on Friday. Tomorrow we will be playing a Kahoot review. Have a good day, guys.